The 8536 series motor starter is a type of electromagnetic switch used to provide a safe and controlled method for starting and stopping electric motors. A motor starter typically includes overload protection to prevent damage to the motor in the event of an overcurrent condition. Let's discuss how to use the normally open, commonly abbreviated as NO, contacts and how to integrate an emergency stop circuit. To utilize both sides of the normally open contacts, you can wire the start circuit in a specific configuration. Firstly, connect one side of the normally open contacts to the S terminal of the motor starter. This terminal is usually designated for the start signal input. Secondly, connect the other side of the normally open contacts to the tone terminal of the motor starter. The tone terminal is typically one of the power terminals connected to the motor. Thirdly, connect the T2 terminal of the motor starter to the other side of the start circuit. The T2 terminal is another power terminal connected to the motor. The emergency stop, commonly called e-stop, should be wired in series with the start circuit. This arrangement ensures that when the emergency stop is activated, the start circuit is immediately interrupted, causing the motor to stop. When wiring the emergency stop, it's crucial to use a normally closed contact on the emergency stop switch. This is because in a normal, non-emergency state, the circuit needs to be complete to allow the motor to start. When the emergency stop is activated, the normally closed contact opens, breaking the circuit. Let's look at some considerations for wiring motor starters. The National Electrical Code, often abbreviated as NEC, provides guidelines for safe and proper wiring practices. Always refer to the latest edition of the NEC for the most up-to-date requirements. Wire size is critical for ensuring safe operation and preventing overheating. The NEC Table 310.15b16 provides ampacity ratings for various wire sizes based on insulation type and temperature rating. Select a wire size that is appropriate for the motor's full load amperage, also referred to as FLA, and any applicable directing factors. Overload protection is an essential component of a motor starter. Overload relays are designed to protect the motor from overcurrent conditions that can cause damage. These relays typically have adjustable trip settings to match the motor's full load amperage. Short circuit protection is also necessary to protect the motor and the electrical system from high fault currents. Fuses or circuit breakers are commonly used for short circuit protection. Select fuses or circuit breakers with an interrupting rating sufficient to handle the available fault current at the installation location. Control voltage refers to the voltage used to operate the motor starter's coil. Common control voltages include 120 volts alternating current, often abbreviated as volts AC, and 24 volts direct current, often abbreviated as volts DC. Ensure that the control voltage matches the voltage rating of the motor starter coil. Enclosure type depends on the environment in which the motor starter will be installed. Enclosures are rated based on their ability to protect against dust, water, and other environmental factors. Choose an enclosure type that is suitable for the specific application. Grounding is essential for electrical safety. Ensure that the motor starter and the motor are properly grounded to provide a path for fault current to flow back to the source, tripping the overcurrent protective device. Control wiring refers to the wiring used to connect the motor starter to control devices such as push-button switches and programmable logic controllers, often abbreviated as PLC. Use appropriate wire sizes and wiring methods for the control wiring. Motor starters are available in various sizes, designated by NEMA sizes. The NEMA size of a motor starter is determined by the motor's horsepower rating and full load amperage. Select a motor starter size that is appropriate for the motor being controlled. Motor starter components include the contactor, overload relay, and control transformer. The contactor is the main switching device that makes and breaks the motor circuit. The overload relay protects the motor from overcurrent conditions. The control transformer provides the control voltage for the motor starter coil. Three-phase power is commonly used for industrial motors. Ensure that the motor starter is properly wired for the three-phase power supply. Check the voltage and phase rotation to ensure correct operation. Single-phase motors are also used in some applications. Motor starters for single-phase motors typically have different wiring configurations than those for three-phase motors. Reversing starters are used to reverse the direction of rotation of a motor. These starters typically include two contactors and a mechanical interlock to prevent simultaneous energization of both contactors. Reduced voltage starters are used to reduce the starting current of a motor. These starters can help to minimize voltage drop and mechanical stress on the motor and driven equipment. Variable frequency drives, commonly called VFD, are used to control the speed of a motor. VFD provide precise control over the motor's speed and torque, and can also improve energy efficiency. Solid-state starters use solid-state devices to control the starting current of a motor. These starters offer smooth and stepless starting, and can also provide overload protection and other advanced features. Across-the-line starters are the simplest type of motor starter. These starters apply full voltage to the motor terminals upon starting. Arc-winding starters are used to reduce the starting current of a motor by applying voltage to only a portion of the motor windings during starting. Y-delta starters are another type of reduced voltage starter. These starters connect the motor windings in the Y configuration during starting and then switch to a delta configuration once the motor reaches a certain speed. Autotransformer starters use an autotransformer to reduce the voltage applied to the motor terminals during starting. These starters provide adjustable starting voltage and current. Primary resistor starters use resistors in series with the motor windings to reduce the starting current. These starters are simple and cost-effective, but they can also result in significant power loss. It is important to regularly inspect and maintain motor starters to ensure reliable operation. Check the contacts for wear and damage, and replace them as needed. Clean the enclosure and components to remove dust and debris. Test the overload relay to ensure that it is functioning properly. Troubleshooting motor starters involves identifying and resolving problems that can prevent the motor from starting or running properly. Common problems include tripped overload relays, blown fuses, and faulty contact. Use a multimeter to check voltages and currents, and inspect wiring connections for looseness or corrosion. Motor control centers, abbreviated as MCC, are used to house multiple motor starters in a centralized location. MCC provide a convenient and organized way to control and protect motors in industrial facilities. Programmable logic controllers, also abbreviated as PLC, are used to automate motor control functions. PLC can be programmed to start, stop, and control motors based on various inputs and conditions. Human-machine interfaces, commonly called HMI, provide a user interface for monitoring and controlling motor starters and other industrial equipment. HMI can display motor status, alarms, and other information. Motor protection relays provide advanced protection features for motors, such as overcurrent, undercurrent, overvoltage, undervoltage, and phase imbalance protection. These relays can help to prevent motor damage and downtime. Soft starters provide a gradual start for motors, reducing mechanical stress and voltage dips. Soft starters use solid-state devices to control the voltage applied to the motor during starting. Motor disconnect switches are used to isolate the motor from the power supply for maintenance and repair purposes. These switches should be lockable in the open position to prevent accidental energization. Control transformers are used to step down the voltage for the motor starter control circuit. These transformers provide isolation and protect the control circuit from voltage fluctuations. Surge protection devices are used to protect motor starters and other electrical equipment from voltage surges caused by lightning or other electrical disturbances. Terminal blocks are used to provide convenient and organized connection points for wiring. Use appropriate terminal blocks for the wire size and voltage rating. Wiring ducts are used to protect and organize wiring within the motor starter enclosure. Use appropriate wiring ducts for the wire size and quantity. Cable ties are used to bundle and secure wiring within the motor starter enclosure. Use appropriate cable ties for the wire size and environment. Labels are used to identify wires and components within the motor starter enclosure. Use clear and durable labels to ensure proper identification. The information provided is a general guideline and may need adjustments based on the specific motor and motor starter. Always consult the manufacturer's instructions for the specific device being used. If unsure, consult a qualified electrician or electrical engineer.